Okay, so we're at the, again, we're going to see a series of questions over here. And just looking over it, you might say, which one do I do first? The one that you think is the easiest, you need a confidence builder before you move forward in a problem set. And, I'm not going to say the first one's the easier, second one, whatever. You look around. And, certainly I have preferences. And I'm kind of looking around real quick, too. I'm going to say 3 looks like the easiest one for me to do. And the first thing I notice about 3 is this, again, assumptions being made. It looks quadratic in form. And what I mean by that, I'll write this one down for you. 2 to the 2x minus 8 times 2 to the x plus 12 is equal to 0. And to make it look quadratic, I'd say u is equal to 2x. And then you'd get u squared minus 8u plus 12 equals 0. And then I try to factor it, right? U and u, 0. U times u is u squared. And I'm going to say minus 2 minus 6. And that does work out. Now, u could be 2, or u could be 6. I don't want u, though. I want x. So I'm going to say 2 to the x, which is what u is equal to 2, or 2 to the x is equal to 6. Well, the first one looks pretty easy. X has to be the number 1. The second one looks more difficult to me, by the way. But I know it's between 2 and 3. But I don't think they're asking me to approximate it. They're just asking what the number is. So I would take the log base 2 of both sides. I'll write this down for you. 2 to the x equals log base 2 of 6. And you're going to get what? You're going to get, on the left side, you just get x, right? Because x comes down, and log base 2 of 2 is just 1. And then log base 2 of 6 is the same thing as 2 times 3. So x would be equal to log base 2 of 2, which is 1, plus log base 2 of 3. This is probably the simplest answer I could write down. So I'm going to say x equals 1, or x equals 1 plus log base 2 of the number 3. I'll put it in a box. I'm going to look at the answer key, and as I do that, that's number, what number was that? That was number 3, right? Now, that's confidence builder. Even if I got it wrong, it's a confidence builder. I feel good about it. I feel like I did a right answer. And let's take a look. Whoops. So x is 1. Now, they're writing something different. They're using log base 10. All right, that's up to them. You could also base A, whatever. I use base 2. So equivalent answer. Again, yeah, same answer. All right. So let me go back. And I'm going to look for another low-hanging piece of fruit here. Let me look back over it. 1 doesn't look bad. 2 looks really nightmarish. It does. 4, I hate these type of problems where people are talking to one another. Have a hard time keeping track of the characters. I'm going to try number 5. All right, now I'm going to read. It says, it's a straight 1 mile stretch of highway 40 feet wide. So 40 feet wide. You ride your bike on a path composed of semicircles. I see that. All right. And you ride the bike at 5 miles per hour. How many hours will it take for you to cover the 1 mile stretch? Well, again, I want to point out he's not going straight. He's like in a zigzag motion here. All right. So the first thing I do is I want to make sure that there's a footnote over there. And they tell me the mile is 5,280 feet. So the linear distance here, the distance he has to go is 5,280 feet. That's the total distance. Now his rate, his speed that he's traveling, the rate is 5 miles per hour. I'm going to convert that to feet because it looks like they're just speaking in feet. So there's going to be 5,280 feet in every 1 mile. And again, if you didn't know that, that's in the footnote. I can understand not knowing that, by the way. So his rate is going to be, I'm not going to multiply that because he's not asking that question. So it's 5 times 5,280 feet per hour. All right? So what I'm going to do is I'm going to try to determine the path he's taking. And I'm just going to look at, this over here. And, if I did that, maybe a different color maybe. So I'm going to say he does something like this over here. And I'm going to say, if I looked at that, he would go what? Well, if I look at that, that's a diameter of the circle, which is 40 feet. So when he does one circle is going to be the same thing as doing, and this is, again, one circle. If you look at it, it's two halves of circles, one circle. He'll actually do 80 feet. All right, now when I say 80 feet, it's 80 feet towards his goal. His goal is to get over here. But he actually rode his bike more than 80 feet, didn't he? So to do the 80 feet, he actually did a complete circle. And the circle, the circumference of that circle, its radius would be 20, right? 20 feet. So one circle is actually equal to 2 pi r. And the r is 20. So that's going to be, what is that going to be? That's going to be 40 pi feet, right? So I want to make sure you know he's got to do a certain number, right? So the question is, what's the number of circles he has to do that, right? So the number of circles needed. Let me go back to black ink. So let's see. Well, one circle, right, this is one circle over here, is just 80 feet, right? So the number of circles he needs, right, that's a complete circle, by the way, is going to be 5,280 divided by 80, right? Because each circle, you can get 40 feet here and 40 feet here, the diameters, right? So that's going to be, let me just write this down. So he needs 528. Well, we don't need to do the arithmetic. I'll put it over 80, all right? That's how many circles he needs, all right? So this is, again, this is the number of circles. And each circle, let me write this down, 5,280 over 80. But every circle he does, even if it's a fractional circle, it's going to be worth this number of feet. Right, so I'll write this down. It's going to be 40 pi feet. This is going to be distance, and that's going to be equal to the rate times the time. I don't know the time yet. So let's see, what's the rate going to be? Well, the rate's over here. This is how fast he's riding his bicycle. All right, so he's going to go 5 times 5,280 feet per hour for t hours. All right, let's see if we can do that now. And the first thing I'm going to do, let me get my eraser. I don't need this stuff down. I understand this now. I'm going to start to maybe do the arithmetic now, or the algebra. And let's take a look at this. So I'm going to say 40 goes into 40 once, and it goes into 80 2 times. All right, let me put this in red. I'm going to say the feet cancel, divide both sides by feet. The 5,280, divide both sides by that. I'm going to divide both sides by 5 now. So what are we left off with? Now, I'm going to bring the hours over here. And what are you going to get? Multiplying both sides by hours, by the way. And you're going to get pi. You go back to black ink. Divide by 10 hours. Let me see if I did okay there. I got the 5,280 disappearing. 40 and 80 is 2. 2 times 5 is 10. Yeah, I'm pretty much convinced. All right. So a little confusing problem, I'll be honest with you, but we got through it. Let's just take a look at the answer. I mean, as I got through it, I got to the end of it. It's a confidence builder, including if I got it wrong. I won't know that until I got the test back. But that's number 5, right? Let's take a look at number 5. And number 5, yeah, right here. All right? And there's, again, this is me cleaning the problem up, writing it down in the blue area. All right, let me go back to the problem set. I'm going to look around. And I'm going to go to number... I'm going to go to number 1. And number one, it's about a stock. And it says every day the value of the stock rises by exactly $2 in the morning and then falls exactly $1 in the afternoon. I understand that. If the stock's value at the start of the first day is 100, let's write this down. A1, that's the first day. It starts at 100, but remember, it rises by $2, right? So it says every day the value of the stock rises exactly $2 in the morning. So if it starts at 100, it would be $102 in the morning. But then what happens is in the afternoon, it drops another dollar. So it'll be 101. So I'm write down A2. Now remember, the starting price on this would be 101, but then it increases by 2, so it'll be 103. And then it drops to 102. It drops a dollar. And not that I want to keep doing this, but you could. And this would be 104. It rises by 2 because it closed at 102. And then it drops by 103. And I think you see the pattern over here. Question is, what's their question? It says, every day the value of the stock rises exactly $2 in the morning and then falls by exactly $1 in the afternoon. If the stock's value at the start of the first day is $100, on what day? I don't know. I'll write this over here, AN. On what day will the stock's value first reach $200? So, I hope you're looking at this sequence and you're seeing it, right? And I'm going to say they want it to be 200. Now remember this. They want it to get to 200, right? And then it's going to fall back down to 199 at the end of the day, right? So I wonder what AN is going to be. Now to do this, I want to point out it's really not bad. I'm kind of just focusing in on the numbers here. By the way, if I did AN minus 1, I'll write this one down for you. What would that be? 199. And this would be, what would that be over there? All right, if we're going back to this one over here, well, it'll be 198, right? I hope that's not confusing to you. Okay? Let's write this down, A1. I want to tell you what we're focusing in on now. We're focusing on this guy over here. This is the greatest number in each sequence. We're focusing on this number over here. I want to see if we get a pattern to it. And I'll write this down as 100 plus 2. We're just focusing on the green part now. And then A2 would be 100 plus 3. And A3 would be 100 plus 4. We want to get to AN, though. And AN would be what? It would be 100 plus 100. I want to focus in on the pattern of here. 1, 2, 2, 3, 3, 4. It's up by 1, right? So would the N be going to be? That'd have to be 99. So it's going to be A99. So A99. So what's N? N would be 99. So it happens on the 99th day. Let's take a look at the answer key, see how we did. And this is number, what number is that? Number 1, right? Yep, day 99. All right, day 99. All right, again, it's right up in the blue area. I got to go back and I'm going to start to erase things now. All right, I'm going to try to see if I can do another problem here. And I'm going to erase one. One wasn't that bad. So, again, I'm getting some confidence builders here. And now you might get a confidence destroyer here. Now, again, people have personal preferences, and my preference over here is that, again, I did this one. I did all right with that. We looked at the key. We did okay. I think you remember me doing that. I use different logs, though, right? I use log base 2 and I use log base 10. Use any log you like, all right? Don't think one's better than the other. Now, granted, if there's a grader there and they're looking, they might have to decide between two people's exams about who did a better job there, the guy who did log base 10 or the guy who did log base 2. That's kind of a judgment call, and you could disagree with that, but that does happen sometimes. All right, so I'm going to claim over here, this is just me, by the way. 4 looks like a really tough problem to me. I'm not saying it is, it just looks tough to me because there's people talking, they're saying things, it may be distracting me with all that talking, their names are confusing. I'm going to see if I can do number 2. And I'm going to read it first. And it says a diagram below. I like the diagram. I can't remember where I got this question from, but I saw the question. I thought it was a good question. And like a lot of things you see, whether I saw it on a paper exam somewhere or I saw it on the internet, just can't really remember. But I thought it was an interesting question. And I want to point out, looking at it, I'm reading it in the diagram below. I have to correct the numbers, by the way. I notice that my numbers are off. Don't worry about it. It says, I'll correct that. You won't see this in the document. A triangle, let's see. I see the triangle P0, P2, P1. Yeah, I see that. It's equilateral. Well, it's certainly a good picture. It says the sides are length 1. Well, maybe I should write that in now. So these sides over here are all length 1. All right? And then it goes on the lengths of the segments, P0 to N naught. I'm looking around for that. Yeah, that says 4. It's clearly labeled. And P1, N1. Let me see if I see that. P1, N1 is 3. Yeah, I see that. Nicely labeled. And then they say the length of segment P2, N2. Let me take a look at that. Yes, 2. I see that. And then they say X is P naught, M naught. I see that. And they say that Y is P1, M1. Let me see if I see that. Yep, I see that. And Z is P2, M2. All right? And they want me to compute X plus Y plus Z. Well, you know what? I would need to know, something about this, what's called a chord theorem. And the intersecting chords, I'm going to do one at a time now for you. And the intersecting chords I want to do this chord here. Let me just, sorry about that. I'm going to do a highlighter here. This chord here and this chord here. Now, what I know is I intersect at a point, and what I know about the intersecting chord theorem is that the product, I'm going to write this down for you, of this side, which is X naught, times this side, right? So that's going to be 3X, right? So the product, that's going to be 3X. And put it back in black. Is going to be equal to this guy's product. And what's that going to be? Well, that's going to be 4 times, I'm looking at it, the product of that, the point intersecting 4, and then 1 plus Y. And this is the intersecting point P naught. All right, let me get my eraser out. And I'll erase this business over here. We're using the intersecting chord theorem. If you didn't know that, this would be a really tough problem, by the way. I'm going to put down P1 now. And P1 is this point here. So let's do the product of the lengths of the chord for that would be, let's see, Y times 5, or 5Y. And the other, and again, I want to point out what we're looking at. We said P1, right? So this is the chord that goes through P1, and this is the other chord that goes through P1. And let's write down the product of their, so it's going to be 5 times Y, and then 3 times, looks like 1 plus Z, right? And now let's put down the next one. Let me erase this business over here. So let's say we did P naught, we did P1, now I'm going to do P2. The chord's going through P2. So the chord's going through P2. This goes through P2. It's a chord that goes through that. And this chord goes through P2. Let's write this one down. Let's hope it's going to be easy. So what you're going to get? You can get X plus 1 times 2. You know what? I'm going to make that below it, okay? So it's going to be 2 times, sorry about that. It's going to be 2 times X plus 1. And then the other chord's going to be 4 times Z. Now, what's their question, though? And this is the tough part, knowing what their question is. They want me to compute this thing over here. All right, I got to clean it up. All right, let me erase this over here. I'm done with that. I got all my 3 intersecting chords now. Got 3 different equations. And let me kind of clean it up a little bit. So P naught is going to be 3x equals 4 plus 4y. And the next one's going to be 5y equals 3 plus 3z. And then the last guy is going to be, 2x plus 2 equals 4z. Well, I'm going to look at this and see if I can write it like I would in an algebra class, right? I get x, y's, and z's. Let me take the first equation. You get 3x minus 4y. There are no z's, but that would equal 4. That's the first equation. The second equation, what do I see? I would see no x's, but I see 5y minus 3z's is equal to 3, right? And let's do this last guy here. What would I say? I would see this would be 2, and then I'd get 4z minus 2x, right? And I'm going to put a little line over here. And the reason I'm doing it, I'm noticing something nice about this. If I did add together, all these three equations together, what do you get? X plus y plus z is equal to 4, 5, 6, 7, 8, 9. All right, let me look at the answer key. And this is problem number 2, right? And they say 9. All right, I also want to point out, I realize it, and don't stress over this. All right, I mean, even if you study it, you can't remember it. It's possible that you studied it. Possible someone proved it for you. Possible you might even proved it. You just can't remember. But anyway, I write the intersecting chord theorem down for you, or just a chord theorem. All right, write down if you want to read through that. All right, but anyway, it's stated. Okay, here comes a tough one that I believe is tough anyway. This one over here. All right, so I'm going to do, I'm going to go to the answer key. I just want to talk through it. This is the last problem. Now, certainly, I say this one for last because I thought it was the most difficult problem, but it says one day in December, 3 two-digit prime numbers, A, B, and C, were given to 3 members of the ECC math team. So I understand why they're using A, B, and C. They represent the names of these people. But what A is some kind of prime number. Now, if they've given a 2-digit prime number, I want to point out 2-digit prime numbers, you couldn't put down like 7, for example. But what's the first 2-digit number? 10, but that's not prime. So 11 would be prime, right? Let's see, 12's not good. 13's good. Maybe that's one of the numbers they gave them. And then 14's not good. 15's not good. 16's not good. But 17's okay, right? And let's see what else you got. 18's no good. 19's okay. I'm just doing the 2-digit ones. And let's see. 20's no good. 21's no good. 22's no good. 23's okay. 24's bad. 25's bad. 26 is bad. 27's bad. 28's bad. 29's okay. And then 31. All right? So that's just reading the first part. But then I'm reading these conversations to them. They said, if you add your numbers, we get precisely today's date. Well, I'll tell you what, I don't think 31 could be one of those numbers. Right? Because 31 does any other number. I don't care what the number is. Right? If you add your numbers, we get precisely today's date. The next one I'm going to say, it says, if we add your numbers. By the way, when A speaks, he's talking about B and C. When B speaks, he's talking about A and C. And when C speaks, talking about A and B. But it seems like they're all talking about adding numbers together. Right? If we add the numbers together, we get my birthday this month, which was before today. If you add numbers together, oh boy, there's always adding numbers together. So 31 could not be, because 31 plus any of those other numbers would be outside of the set. And the set's got to be 31, right? 29's not going to work either, right? And this is good. I get rid of that. There's 29. Any other number is just not going to be in the set. It needs to be outside. Let's see, does 23 go? No. 23 plus a smaller number is outside the set, right? How about 19? Yeah, 19 works because 19 and 11 would be 30, right? So what I want to do is I want to erase the numbers that it can't be. Sorry, I erased too much there. Sorry about that. They go up to 19. I'm sorry about that. Right, here comes the problem now. Oh, by the way, certainly I know this is a difficult problem. You may want to think about what's been stated over there. I'm just saying that A, B, and C must be over there. By the way, people could be given the same number. All right, let's write this down now. This is A speaking. So A is talking about B and C now. It says over here, if you add your numbers together. So what A is saying that if you add B and C, right, if you add your numbers, we get today's date. I'm going to write that down. That would be today's date. All right, let's talk about now this person talking. That's B, right? Who's she talking about? A and C. So A and C, if you add your numbers together, we get my birthday this month, which was before today. So I'm going to say it's less than today's date. Now let's go to this person over here, and she's talking about A and B, right? So when A and B get added together, this gets tough, by the way, a lot to keep track of. If you add your numbers together, we get my birthday this month, which is after today, which means it's greater than today's date. All right, I got a relationship over here. It's a difficult relationship, but I have a relationship. And I got B plus C, which is today's date. And I got something bigger than it, and I got something smaller than it. Now, what's bigger than it? A plus B is bigger than it. I read that part. And what's smaller than it? A plus C. So I have sort of an ordering to this. And I want to point out what I mean by that. I have A plus C is less than B plus C. All right, by the way, my numbers are in this set over here. I know that much. So what is that saying? It's saying A is less than B. Now, I just did this part. And let me do the other one. It's going to be B plus C is less than A plus B, right? So what does that say? It says that C is less than A. Let me see if that's true. Take C from both sides. I'm sorry, B from both sides. You can see is less than A. Yeah, I think I have something over here. All right, I got that part done. All right, let me just start to see what they're going to say now. And again, I got this over here. 11, 13, 17, 19. Let me read this again. One day in December, 2 prime digit numbers. I had a conversation. Oh, what did Carlotta get? Well, Carlotta's the smallest number, right? So Carlotta, and again, these are ordered numbers. I guess Carlotta could get 11 or 13, right? So I write this over here. I mean, I could write this down. I could write 11. And then A could be, a number up from that. You know what I'm going to do just to make it a little bit easier for me? I'm going to say Carlotta is 13 and see if this makes any sense. Because if that doesn't make sense, then I have to jump ship. So 13, and then A would be 17, and B would be 19. Now, if this doesn't make sense, I know Carlotta would have to be 11. All right, let me see if this makes any sense, though. Let's say Carlotta is 13, A is 17, and B is 19. Let me go back and read it. So A says you add B and C together. That can't be. Because if you add B and C together, what would you get? You get 32. This can't be the case. So Claudia's going to be 13. I just want to check it, but it's going to be hard to check, right? So I'm going to say, I got to conclude this now because it's the only choice. So Carlotta's got to be 11. All right? There's no reason to check it at this point. Yep, 11. All right, 11. All right? And again, I'm using inequalities to do that problem. All right? Again, I checked up to 13 because it's easy to check. 11 is more difficult to check, by the way, but it can be checked. All right? You can play around with it. So I'm going to claim over here we're done with this, and it was tough. So I want to just go back to the original set of problems and tell you what I thought was the easiest one to do. All right? So let me just get my eraser out, and I'm going to start to erase this over here, get back to a clean sheet of paper. Boy, it would be nice to get this set of problems on an exam, and you'd say, oh, gee, I know all the questions and how to do them. So let me just go through what I thought was the easiest one to do. And again, this is opinion, right? You may say, no, this is easiest for me to do. Like, you may think 4 is the easiest one to do. But I got to be honest with you. I really do believe 3 was the easiest one for me to do. If I think about the next easy one, I'm going to say this one over here was also fairly easy to do. The next one on the list of things for me easy to do was this problem over here. It really wasn't that bad. It did require some thinking and reasoning skills. Yes, mistakes can happen when you do that. The ones that were difficult for me were 2. But if I knew that intersecting chord theorem, right, if I knew it. Now, if I didn't know it, this would be impossible. This was really easy if I knew the intersecting chord theorem. I got to be honest with you, though. This one over here was perhaps the toughest one for me to handle. It required reading and thinking about what they said, all right? And that's a problem. It takes time, all right? Here's the deal, though. I realize as I'm looking at my work and saying, now you had a better way of doing things, or I have a question, whatever. I'm around. If I'm not being overwhelmed by emails, I'll respond to you. My email address is Bannon. That's B as in boy, the @ symbol, NNON.US. And again, what I'm saying about this over here is that you're more than welcome to reach out to me. All right. Now, what I mean by that, if you're reaching out to me about this and you got a question, let me know what your question is, and I'll try to get back to you. However, if I'm overwhelmed with emails, I may not be able to respond to you. You may think you're being ignored. You're really not being ignored. I just can't handle the volume. But again, I can't see it getting to be a large volume, though. So, feel free to reach out to me. All right. Thank you. Oh, by the way, before I mention this, I also want to mention that the document is being prepared for the Prison Mathematics Project participants. So I do plan to publish it at some point. And if you're just reaching out about the publication of this, I'll update you about that as well. But it still needs to be vetted. It still needs to be read over. And, little tiny details need to be corrected. For example, over here, I had the wrong number down for this one over here. And that has to do with, I use the images double. And so when they're referenced, it's actually referencing a different page. It's actually referencing page 292. And that's over here. We see the image again. It does reference. It's there, but it's not the proper spot for it. Okay? So again, if you need to reach out to me, please feel free to do so. If I'm not overwhelmed, I'll get back to you. Thank you. Bye-bye.